Hello and welcome to Advanced Mathematics 1, Unit 9, Part 3, Graphing Square Root and Cube Root Functions. By the end of today's lesson, you'll be able to graph square root functions and graph cubic functions and all of their transformations as we have been doing before. So we just cut to our main concepts for today. As the square root function is f of x equals a square root of x minus h plus k, so that same format. And our domain is everything greater than h in x and everything greater than k in y. So you can see the base graph here. It's going to start at your vertex, and then it's going to curve over to the right and do like a normal function, and if you turn it upside down, that's what that looks like. The cubic function is the same, but with a cube root rather than, I meant a cube root function, sorry. And then the domain and the range are all reals. So it basically looks like the cube function except it's turned on its side. And that's the only difference there. All right, we're going to move on to our first example. And like in every other situation, we start by finding our vertex, and then we deal with the a, which is out front of, in this case, the square root. So let's go ahead and start. So we have our vertex is what makes the inside of the square root 0, and then what's sitting outside of the square root, which is 5. My a is -2, so I'm going to have an x, y, -2, x. So this is going to graph downward from the vertex rather than upward. And we have when x is 1, the square root of 1 is 1. So this would be -2. The next perfect square is 4 after 1. Square root of 4 is 2. And then -2 times 2 is -4. So we're going to start over at our vertex, which is 1, 5. So up here. And then it's going to go up and to the right from there. So when we go over 1, we go, well, it'll be down and to the right because it's negative. So over 1, down 2. And over 4, so 1, 2, 1, 2, 3, 4, we go down 4. So 1, 2, 3, 4. And then we make a nice little curve, just going this direction. And that's it. That's the square root function with a -a. All right, in our second example, we have something inside the square root with the x. So we start by factoring that out like we do with every other problem. So I'm going to write y instead of f of x, and I'm going to separate it out. So it's literally 1/16 times x. And then we go ahead and separate out the square roots. So it equals the square root of 1/16 times the square root of x. And now we just simplify that. So y, the square root of 1/16 would be the square root of 1 over the square root of 16, which is 4. And then we have the square root of x. So in this case, my vertex is 0, 0, because there's nothing inside or outside of the square root with anything. And then we have a y of 1/4. So I'm going to do that over here. X, y, and 1/4. So this will be normal. It will go up and then to the right. They always go to the right. So that's easy to remember. So when x is 1, again, the square root of 1 is 1. 1 times 1/4 is 1/4. So the next one will be 4 again. Square root of 4 is 2. And 1/4 times 2 is 1/2. We'll try and do one more. So the next perfect square would be 3 squared, which is 9. So square root of 9 is 3. 3 times 1/4 is 3/4. Still pretty small. Let's try and do one more. 9, let's see, 4 squared is 16. So that's 4. And then 1/4 times 4 is finally 1. So you can see this is pretty tiny as far as up and down is concerned. So we're going to plot our vertex, which is at 0, 0. And then we're going to do as much of this as we can. So 1/4 is very, very close, and 1 over. And then 1/2 is really close to that. 2 over, and then 3 over. We get 3/4, which is here. And then finally at, oops, no, those are all wrong. My bad. I can't read my own writing sometimes. Sorry about that. We'll redo that. Oh, sorry. Brain, wake up. Okay, 0, 0. I go over 1, I go up 1/4. That is correct. That part was correct. So barely up. I go over 4, and I go up 1/2, which is here. I go over 9, which is 3/4. So unfortunately, I can't get to that last one. So, but you can see this thing is so tiny, so tiny. It's gonna be hard to draw. Best I can do. There you go. All right, for our next example, we are doing the cube root function this time. It works the same way as before. We find the vertex. What makes the inside of the cube root 0 is -4. What's sitting outside the cube root is -5. This one does not have an a, so it's just a normal cube root function, which is a little difficult because it's cube roots, so we move really far really fast. So the cube root of 1 is 1. The next perfect cube would be 2 cubed, which is 8. And we're not going to be able to probably go further than that, realistically. Okay, so let's plot our vertex, -4, -5. All right, right there. And then we go, it's like the cube function, so it goes over 1 and up 1 on the right, and down 1 and left 1 to, 1 to the left. So, but it's down 1. And now we'll try the 8. So 5 plus 8 would be 5, 6, 7, 8. And that's over at -2. Let's see, 5, 6, 7, yeah, 1, 2, yeah. There we go. And then the other one, I don't think it can go 8, no. 6 and 10 is 4, so it's way, way, way down. Way, way down there. So remember, it's kind of going this way instead of up and down. It's going left and right, like so. All right, last but certainly not least, we have another cube root function, but you can see it's written kind of backwards right now, so I'm going to turn it around. The x should always be first. So we have cube root of -x plus 1. That gives us a number inside the cube root with the x, so that means we have to split it out. So we have the cube root of -1 times x plus 1. And now we'll pull that apart. So we get the cube root of -1 times the cube root of x plus 1. Since this is a cube root, we can take the cube root of a negative number. The cube root of -1 is -1. Now we're ready to graph it. So we have our vertex, which will be what makes the inside of the cube root 0, and what's sitting on the outside, which is nothing. And then we have our little xy chart, because there's an a of -1. So this is going to go backwards. It's going to go to the left first on the top and right first on the bottom. So I have 1, the cube root of 1 is 1, and then -1y gives us -1. Again, the next perfect cubed is 8. So that would be that. 8. 2, the cube root of 8 is 2, and then times -1 is -2. So we'll start at -1, 0, right here, and we're going to go up and to the left by going 1, 1, and 8, 2. And then over here we have going 1, 1 again, and then 8, 2. But going downward, both of them. So we'll make our little curve. That's very bad. Let me start that over again. Sorry. Let's try it again. Oh, that was horrible. There we go. That's a little better. That one's pretty bad, but you get the gist. And that's all there is for today. And I will see you next time.